Greetings everyone. My name is Sanjay Kumar and let us continue with the discussion. In today's discussion, we are going to talk about 5G core network. I'm one of the founder of 𝐃𝐿 and that is a training and consulting company on telecom. Right. So in today's session, just allow me a second. Yeah. In today's session, what we are going to talk about is we are going to talk about a course called as 5G Core Deep Dive, where we are doing the detailed protocol analysis and lab setup. So this is more of a demo session, demos come knowledge sharing session for this particular course. So maybe first 40 minutes we will spend on some of the knowledge sharing on 5G Core. And after that, I'll talk about my course. So even though you are not interested in the paid course, still it may be useful session for you, where you will be able to understand some of the basic understanding about the 5G core network. Now, moving on, in this course, we are going to talk about, in this session, we are going to talk about evolution from EPC to the 5G core network, a high-level overview of the service-based architecture. We will be talking about N1, N2, N3, N4 interfaces and protocols, the UE registration, the PDU session establishment, and this is something which we have excluded from this discussion as of now. Now, moving on, 𝐃𝐿 is a partner or associated with organizations like Bharat 6G Alliance, Voice Consortium, TCOE. We are also a government recognized startup, as well as we are a part of Microsoft Founders Hub program. A little bit about me. I come with around 22 years of work experience, with 17 years I've spent into training, worked with a variety of different organizations, system integrators, OEM, operators, etc. Worked with all the technologies starting from wireline network till 5G network, talking about transmission, IP, core, circuit core, and packet core, as well as I'm a certified AWS certified solution architect and AWS authorized instructor. Worked with a variety of different products, which include Samsung, Nokia, Ericsson, ZTE, Cisco. So this is a little bit about me. If you wish to know more about me, I will be sharing my LinkedIn profile and my mobile number. Feel free to reach out to me on these details. I have trained people in more than 60, 70 companies, different companies around the globe in 50 plus countries. And I've also delivered training in various colleges and universities across India. Right. This is a little bit about me. I will be sharing these links at a later stage in the chat box. Right. So we provide the trainings to the enterprise as well as to the individuals. So this course, what we are talking about is a 5G core network deep dive course, which will spread across 8 to 10 weeks. I will be talking about this course at the end of the discussion. In addition to that, we do a lot of, customized courses, which can range from 1 or 2 days to can go up to 4 to 6 weeks. If you need information about any of these courses, so most of these different courses, they are designed for the enterprise. We are not doing those as open courses. The open courses are like 5G core network deep dive, what we are starting coming Saturday. Right. If you wish to know more about us, you can drop us an email at info@telcolan.com or visit www.telcolan.com. As this is going to be open session, so we will not get into the deep technical discussions or concepts. We have muted your mic, so if you have any questions, either write your questions in the chat box during the discussion, or end of the discussion, we will be, allowing you to ask the questions. So you can raise your hands and then we can take up the questions. Right. The recording of this video will be uploaded on YouTube, and we will be sharing the link in the WhatsApp group. And if you need additional information, please write us to at info@telcolan.com. Right. Now, if we talk about the job scenarios in the telecommunication world, the last few years has been very disruptive in the telecom industry, where in somewhere between 2010 to 2015, the telecom networks, the 4G, when the 4G network started growing in, it was majorly deployed in some purpose-built hardware. That means these equipments used to come as a package of a hardware and software from some predefined vendors. There was a very limited number of vendors, which mainly 5, which includes Ericsson, Nokia, Huawei, ZTE, Samsung. Right. So these were the 4 major vendors for the 4G product. However, at a later stage, we started moving towards the cloud architecture, where the EPC kind of network, the evolved packet core kind of network, are further virtualized. So cloud became a norm in the 5G, in the 4G world at a later stage. Even though most of the network deployment has already happened at that stage, so we did not see a lot of intervention. However, there was some intervention. It did not happen end to end. But 5G from the day one, when we started talking about 5G from the day one, somewhere around 2018, even in the early days, the core network was completely cloud native. So cloud became a one of the mainstream thing in the 5G world. And not only the core network, but even the radio network also evolved over a period of time with the form of Open RAN. And when we talk about this Open RAN also started evolving somewhere around 2018. And the complete architecture of Open RAN can also be built on the cloud native architecture. So basically what we are talking about here is both the radio network and the core network has started moving towards the cloud architecture. And that has disrupted the complete job market in telecom industry. Last couple of years has been not that great because there is a lot of consolidation happens. There was a lot of hype created around 5G. There was a lot of discussion happening about Open RAN. However, as of now, we don't see really a great traction in terms of revenue for the operator and private network and network slicing, edge computing. So there were a lot of buzzwords which were created in 5G. But over the period of time, the consolidation has happened. Now it's a little in the consolidation phase, and we are hopeful that in next 3 to 6 months the things will start picking again in case of 5G network. Now let us get started with our discussion. And in this discussion, we are talking about how we are evolving from the 4G core network to 5G core network. 4G core network, which was called as EPC, Evolved Packet Core. We will not get into the details of each and every network functions, which you see on this picture. You can see eNode B, MME, HSS, PCRF, HEW, PGW. And we are not going to talk about the call flows of these different network boxes. But in our session, in our course, what we do, we typically have a 2 to 4 hour session where we talk about complete LTE EPC network architecture, the major call flows, and the procedures related to the 4G network. Now, there were a few limitations with the EPC. The first limitation was there were too many protocols. And when I say protocol, we were talking about telecom specific protocol. So these protocols, every time you bring in a new network function, every time you bring in new network functions in the telecom networks, you try to create a different set of protocols. But creating a different set of protocol is not always scalable. So every time you want to make some changes in the architecture, you need to build a completely new set of protocols. That's pretty difficult. So now what we are trying to do is, for example, in MME, it has a different protocol towards MSCVLR, different protocol towards HSS, different protocol towards eNode B, and different protocols towards HEW. What we are trying to do here is we are trying to streamline these processes and try to create some usage of some standard protocols like HTTP2. So most of the network function in the control plane of core network. So the core network control plane, the protocol what we use for the communication is HTTP2. What is the meaning of that? We are going to see that in the upcoming slides. The 4G network were not really, open network. They cannot provide third-party APIs where third-party applications cannot access or interact with the third party with the 4G network. However, in the later releases of 4G, we brought in some component called as SCEF, which is called a service capability exposure function. And in 5G, which will be further taken to the next level, called as NEF, network exposure function, where the capability of the 5G core network can be exposed to the third-party services. So we are also trying to create some kind of open APIs of the 5G core network, which can be used by the third-party services to integrate and communicate with the 5G networks. The gateway selection was very inflexible. However, some of these things were later sorted out in the CUPS architecture, not completely flexible, but some flexibility was brought in in the form of 𝐶𝐞 architecture, where what we did was we have separated the control plane and the user plane of HGW and PGW, and that happened at a later releases like R30 and R14. At this stage, we also brought in some new functionality in the 4G core network called as decor and e-decor. Dedicated core network, enhanced dedicated core network. So these were some new functionality brought in the 4G core network to support this kind of flexibility and having some kind of dedicated piece of core network. And these are some of the things which are the enablers for the features like network slicing. So I'm not saying network slicing is not, even though we talk about this network slicing in a way where this is one of the the best feature in 5G network, but network slicing also has seen a lot of evolution in the form of 𝐶𝐶 architecture, in the form of decor, e-decor, etc., which already happened in the 4G network. The last but not the least, the architecture of 4G network in the early stage was primarily built on some kind of purpose-built hardware. So these hardwares and in software used to come from the same vendor. So you have to buy it from Nokia, Ericsson, Cisco, Huawei, ZTE, Samsung. However, at a later stage, we also brought in some capabilities where you can build your EPC in the form of virtual EPC, which can be done on a public cloud and even on a private cloud. So you can choose how you want to build your architecture. Would you like to do it on a public cloud, which may not be a great idea if you look at the long-term scenario, but for a greenfield operator, for an operator who is running at a very, very small scale, even public cloud can be a feasible possibility. But for the large scale operators and long-term scenario, private cloud or maybe operators building their own data center will be a more favorable situation. Now, this is how the packet core looked like in the 4G network. And what we have done here is some of the network functions, they have more or less the similar functionality. So NAS, it became N1, S1C in 4G became N2 interface, S1U became N3, and then MME became AMF, HGW, PGW, control plane became SMF, HGW, PGW user plane become the UPF, PCRF become the PCF, and HSS become AUSF, UDM, and UDR. Please note, even though I'm using these names for comparison, they are not exactly same. So I'm not saying MME and AMF are exactly same. PCF and PCRF. When it comes to deployment, when it comes to architecture, they are very different than the 4th generation of network. We are just trying to create a comparison to understand how they are relevant for the prior generations. This is one of the picture which always comes in when we talk about 5G core network, and this architecture is called as a reference point architecture. So I would like to draw a line here, and this line is here. Now all the interfaces below this line, like N1, N2, N3, N4, N9, N6, they make complete sense. They make complete sense and they will be as it is. However, the numbers what you see here doesn't make any sense. They are just for our reference. And we are not going to use these names and these interfaces in any of our communication. And why I'm saying this, we will understand that in next couple of slides. So even though you see N22, N12, N8, N13, N10, N15, I don't really see any value in remembering and knowing these interfaces. The actual value comes from the couple of slides later, where we talk about a completely different architecture. So the reference point architecture can be done, can be created, but ideally we will not use it. We are just using this particular architecture for our reference. We are just using this architecture for our reference. These are some of the name of the network functions. I'll not get into too many details here talking about each and every network functions as of now, but this is the architecture which makes sense. So if you see, this picture is now changed into this picture. Now, this particular picture, you see that all these network functions, they are created to a single bus, connected to a single bus. And even though they are shown as separate boxes, they are not really the dedicated hardware. They are not really the dedicated hardwares and softwares. They are basically running some kind of virtual machines or some kind of containerized environments where one particular network function is nothing but a collection of microservices. So AMF is not really one network function. It is a collection of microservices, which is typically referred as CNF, Cloud Native Network Function. Cloud Native Network Functions, generally speaking, we sometimes call as a containerized network function as well. So this is what it is. Secondly, they are running on a they may be running on a single piece of hardware. So your AMF, SMF, AUSF, NRF, UDM, PCF, everything is running in a single piece of hardware, which is a general purpose processor or some kind of COTS, commercial off-the-shelf hardware. The third thing here is they all communicate with each other. By using HTTP2 protocol in the RESTful API environments. So put together, even this picture, what you see here is not a complete picture. So as per release 17, there are 28 network functions, which includes 102 APIs. That means these 28 network functions of 5G put together provide 102 different APIs. So this is what we have got. In the 5G core network. Now, how they really communicate? This architecture, what we have seen here, is called as service-based architecture or SBA. Service-based architecture or SBA. And this SBA stack and protocol, the lower layers of SBA stack is nothing but a proper TCP/IP protocol stack. It is nothing but a TCP/IP protocol stack. However, all the 3GPP specific data is written in the form of JSON. JSON is called a JavaScript object notation, which is typically serializing your 3GPP specific data into a text format which can be fit into a HTTP body. So how do we really do this communication? They all communicate with each other with some kind of RESTful API-based communication, communicating over HTTP2 protocol, where we use methods like put, get, delete, etc. The 3GPP specific data is written in the JSON format, JSON JavaScript object notation. So end-to-end communication using HTTP protocols to transport JSON format messages in the RESTful API style. Now, this is something, if you go back here, these are the interfaces, which are typically the endpoints called as service-based interfaces. These are the endpoints for the services. So every time whenever you want to communicate something, you have to send your request like NAMF_COM. That means you are reaching out to one of the service of AMF called as NAMF_communication, right? So this is how all these communications are going to happen. So this architecture is also having two different type of possibility. One is server client request and response. Another one is subscribe and notify. And here we are talking about request and response. So whenever a consumer is trying to consume a service, this is going to send a request to the producer. And whenever producer want to respond, it is going to send a reply message. So any network function can be a producer, any network function can be consumer, and they communicate with each other for providing services or consuming those services. How these network functions are going to publish their information, how these network functions are going to discover that information, all these things are typically we discuss in our course, where we talk about the complete architecture of service-based communication. As I mentioned, all these network functions are broken down into multiple microservices or APIs. All these APIs, what you see here, are not really the, just used as an example. This is not the really final value or final information about all the network functions, because as I mentioned earlier, we already have 28 network functions, and out of those 28 network functions, there is 102 these are 102 APIs. So the picture what you see on the screen is just a high level information about all these network functions. The AMF, for example, we are just using this as an example where AMF provides 4 different APIs. One is the NAMF communication, NAMF event exposure, NAMF empty, NAMF location. And how these files look like. So every API what we are talking about, they are available as YAML file, the YAML file, which is Open API 3.0 file. And in this scenario, I have used a Swagger editor to open the YAML file. In the left side, you see the content of the file. In the right side, you see the same content written in English. So basically, all the data what you see written here, that is written in the JSON format. So what we do is typically we share all these files, and you also analyze these files and look at the structure and other details of these particular files. So this is how all these API files look like, and this is how you're going to configure your AMF in the network. In addition to the main services what we have talked about, there are further breakdown of these services with the name of service operations. So your services are broken down into service operations, right? These service operations also have a proper operation semantics, which can be either request response and subscribe and notify. Now, what is the difference? For example, you are planning to buy iPhone 15. So what you do is you go to market, you go to the Apple store and say that, hey, I want to buy iPhone 15. And they already have this available. And so they'll say, okay, you pay and then you take the iPhone. So you have requested something and you get the service or the product right there. However, if you are trying to buy iPhone 16, for example, which is yet to be released, which is yet to happen. And in that case, what you're going to do is you're going to go to the Apple store and tell them, hey, I want to buy iPhone 16 when it is available. So basically what you're doing is you are subscribing for some future events. You are subscribing for some future events. And whenever those events are happening, you are going to be notified. So the network is going to, the network function is going to notify you whenever that event has happened. So for every service operation, there are some known consumers who can consume these services. That is defined in the 3GPP documentation. So this is just for one network functions. Like that, the details are created and available for each and every network function. Now, let us have a quick overview of N1, N2, N3, and N4 interfaces and protocol. And before we do it, I would like to pause for a minute and take up any questions if you have. So if you have any questions, please drop your questions in the chat box. I'll request you to drop your questions in the chat box. If you have any questions. Okay, so there is a question from Sabir which says, PCF, SF, SM policy and policy authorization should be in one microservices or in different microservices. If you use different microservices, then how it will be communicated related to policy context. So if you see, the policies are available in much finer granularity. Earlier, and let me answer this from a different example. If you look at it, if I talk about 4G network, the MME connects to HSS. MME connects to SGW, SGW connects to PGW, and PGW connects to the PCRF. Right. Now, if you look at this architecture, which was a point-to-point architecture, MME have no access to PCRF and PGW have no access to HSS. So anything what PGW requires, from HSS in the form of subscription data, it has to come all the way via MME. And MME don't have access to the PCRF. So every time it requires anything related to policies, it has to all the way via PGW. Right. Now, in 5G, we have a different architecture. So let's say MME is like AMF. HGW, PGW control plane is like SMF. The HSS, one of the HSS functionality is UDM, and the another one is the policy related thing, which is PCF. Now, both AMF and SMF have direct access to both UDM and PCF, and that allows PCF to break down the policies in much finer granular level, where they can provide any AM or MM related policies to AMF, any SM related policy to the SMF. So I need not to fetch all the information in one go and provide to the other network functions like AMF. AMF can do this thing at their own. So the policy and policy authorization, again, there can be some scenarios where I may not need all the information in one go. So we do go step by step, right? So keeping that in mind, we have broken down these capability in much smaller microservices. That's what we are using. There is another question comes from Vinod. As I understand, all network functions register in NRF and share all information in the form of JSON. So yes, the NRF works like a NF repository function. The NRF works like NF repository function, and every producer. So when you say all network function, I need to consider this from a perspective of a network NF producer NF, and they provide their capability in the NRF. And whenever somebody wants to discover it, they have to send a query discovery request to the NRF, NRF, and that NRF is going to provide you this information for all the available NFs which are meeting the criteria of the request. What is in the form of YAML template? So these are typically all the data is sent in the form of JSON only. I'll say JSON, the kind of, and when we will look at the protocol analysis, you will see all this transfer of information happens in the format of JSON. So that don't worry, we will look at it in a short while. Okay. Now, these are the different protocols. The N1 is nothing but the new name given to the NAS communication, non-access stratum. N2, the protocol is used as NGAP, and N3, the protocol is used as GTPU. The N4 interface, what type of interface it is? Control plane or user plane? What do you think? The interface between SMF and UPF, called as N4, is it going to be a control plane or user plane interface? What do you think about it? Okay, Vinod says user plane, Neeraj says user plane, Sonal says control plane. Okay, any other answers? So this interface N4 is majorly going to be a control plane interface. So most of the functionality of N4 is related to control plane. However, there can be some usage scenario where we may also need to implement the user plane architecture in the N4 interface. So for control plane, it is going to use a protocol called as PFCP. In the user plane, it is going to use GTP U protocol, right? So both control plane and user planes are possible in the N4. Generally speaking, control plane, but some specific use cases, we may require user plane architecture as well. This is a quick comparison between the terminologies of 4G and the terminologies of 5G. So IMEI is called as PEI, MSISD is called as GPSI, IMZ number is called as SUPI, which is further concealed using SUKI. MME is equivalent to AMF, HEW control plane as SMF, user plane is UPF. HSS is broken down into UDM, AUSF, and UDR kind of functionality. PCRF is PCF, bearer is called as QoS flow now, PDN connection is PDU session, PDN is now named as DN, APN is called as DNN or data network. While they are very similar, so these terminologies are very similar, but they are not exactly same. So that is something what we need to keep in mind. Even though they are very similar, they are not same. They are not same. Now, in the UE registration procedure, there are slight differences in 4G and 5G network, right? And the second thing is, even for the basic initial registration, even though we are going to talk about only one scenario, this one scenario is only one out of 8 to 9 different scenarios. So even your initial registration can have variety of different options available depending on what type of identities provide, depending on who is the entity who is getting this information. Like, is it the same AMF? Is it going to be the new AMF? Is it happening as a fresh registration? Is it happening as a re-registration? Depending on those things, it is going to have 8 or 9 different options as of now. Now, what are the 3 major differences? In 4G, home network just provides the information. That means the authentication vectors, etc., comes from the home network, but once it provides to the serving network, home network has no control on that. However, in 5G, the final decision on authentication is taken care by the home network. So the architecture for authentication framework is little different than 4G. So in 4G, you provide the information to serving network. After that, everything is done by serving network. In 5G, you don't rely on serving network and you do a second level of authentication in the home network. IMSI is sent in the clear text during registration. However, in 5G, you don't send SUPI in a clear text. You use a concealed version of it, which is called as SUCI. Default bearer is set up during the registration. Setting up a default PDU session is not mandatory during registration. So these are the 3 major differences in 4G and 5G initial registration. Now, even though I just tried to create a quick slide on this typically expands to at least 7-8 different slides, where the initial registration is triggered by the UE. UE is going to send it as a NAS registration request message to the G node B, and G node B is going to send this message to AMF after doing the AMF selection. Now, if AMF has to have some information from the home network, it is going to ask AUSF, AUSF is going to ask UDM, UDM is going to ask to UDR, and after having all these procedures, your AKA authentication and key agreement is going to happen. After that, we are going to enable the NAS security, AS security, and going to create a UE context. And in addition to that, AMF is also going to fetch policies. So we spoke few minutes back where AMF can also fetch the policies from the PCF, which can be related to the AM or MM, access management or mobility management, or also the UE related policies. And finally, it is going to provide all those policies along with the registration accept message. And finally, the UE is in the mode of registered mode. No PDU session created. This is a very, very simple picture, but if you want to get into little more detail, what you can see here is, this is how the protocol log looks like. Sorry. So you see this, all these protocol logs. Second. Just give me a second. Okay. Right. So what you see here is the protocol messages like NGAP, the NGAP setup between GNodeB and AMF, the initial UE message and the registration request, and then all the communication between AMF, NRF, AUSF, UDM, UDR, and finally the authentication request going to the user, authentication response coming from the user. And similar to this, we also have protocol logs, right, where we talk about PDU session establishment involving SMF and UPF, right? PFCP association, etc. Right. So this is just some of the protocol logs what we typically discuss in our training sessions, where we talk about all these service-based architecture, communication, step-by-step method, all the protocol, their information elements, etc. in our discussion. Right. So this is how the typical architecture of the communication looks like in the PCAP logs. Right. Similar to this, the PDU session establishment, where we will also see the involvement of SMF and UPF. So at this stage, whenever a user is triggering an application, we are sending this request to AMF. AMF is going to choose SMF and interact with SMF. And in turn, SMF is going to interact with PCF for all policy related things. SMF is going to interact with the UDM for any information related to session subscription management data, and it is going to interact with the UPF for creating any PFCP association. Once all these things are completed, it is going to inform the AMF, and in turn AMF is going to inform the GNodeB, and GNodeB is going to inform the user, and your PDU session will be established, so you will be able to send and receive data from the user to the user. Right. Similar to this, we also have the protocol logs, which we discuss pretty much in detail in our course. Right. So all these things what are happening at end. And one interesting thing here is, even though this is a very, very simple architecture, depending on the number of PDU sessions user wants to create and number of slices user wants to create, right? We may have more than one SMF and multiple UPFs for every PDU session involved. So I can have UPF chaining, UPF branching, UPF, some intermediate UPF, some PDU session anchor UPF. So there are a lot of different architectures, are possible depending on how many PDU sessions users are requesting, how many slices user is connecting to. According to that, there may be multiple SMFs and UPFs will be available. Right. So this is something, the complete procedure and the discussion we have in our session. Right. So that's all what we had for as a knowledge sharing session. Right. If we will take your questions in a couple of minutes. Before that, right. So this is something what I've already explained, 5G core network deep dive course, what I'm starting next week, going to be 8 to 10 weeks. What is going to be the breakup? I'm talking about that in the next couple of slides. In addition to that, we offer a lot of programs for the enterprise, which can be completely customized based on the requirement you have got. Right. We will take a question in a while, but this course I'm starting on 13th of July. The timing will be 11 to 1 p.m. IST in the morning. We will have these sessions. Okay, so we will have these sessions on Saturdays and Sundays, because most of the working professionals are available only on Saturdays and Sundays. If we get some, this one batch we are starting for sure, but another batch is still, if we get enough participants for the evening batch, we may do it. We may start another batch in the evening time of IST as well. What is going to be the coverage? We will start with the introduction to 5G core and telco cloud, introduction to 5G core network architecture, talking about all the protocol interfaces and procedure, talking about telco cloud infrastructure, open source software for 5G core network, advanced features and security in 5G core, integration and interoperability of the 5G core network, and some kind of hands-on project. So unlike my previous batches where most of these discussions were in the slides and we did some kind of hands-on, in this course, what we are going to do is from the session 2 onwards. So when we start with session 2, onwards, we will start with the hands-on. That means from the session 2 onwards, we will start setting up the labs, and we will set up at least 2 to 3 labs using Open 5Gs, Free 5GC, UERAN, CMS, RSRAN, and or Magma Core, etc. So we will set up at least 3-4 different labs, try to set it up, try to download the Wireshark logs, take out those logs, analyze those logs, run some kind of test cases using those labs, change few things, try to change some parameters and see the failure, see the logs. So all those things, all those hands-on, we are going to do starting from the session 2. So this is going to be a completely hands-on session, hands-on course for the next 8 to 10 weeks. So even though I've defined the curriculum for 8 weeks, sometimes we are not able to complete the whole discussion in 1 week. So we have to, take it to the next week as well. So I'm assuming that even though I've defined 8 weeks, it may go up to 10 weeks, where every week we will having 2 hours of session, and every day in Saturday or Sunday, we are having 2 hour session, 4 hours every week. So put together, it is going to be a 40 hours kind of session. This is going to be 40 plus hours of online live sessions, detailed protocol analysis with logs. It will be spread over 8 to 10 weeks on Saturdays and Sundays. Session recording will be available for 6 months on the web and application. Even after completion of the course, support session will be available. You will be able to build your own labs and use it forever. We are going to give you the best collection of reference material, which is going to be $500 plus US kind of pricing, resume review, LinkedIn profile review, and interview preparation. And in our network, whenever we get some 5G core related positions, we are also going to refer your profiles there. So this is what we have got. The pricing of the course is going to be a little flexible. So first installment, to start the session, you have to starting with the second class, which is going to happen in the next week. You just need to spend $49 or $4,999 with GST. If you're not okay to pay GST, we can discuss that as well with some other mechanism of payments. The second installment, after completing 4 classes, it will be $149 US. After completing 8 classes, you have to pay $249 US. Total price is $447, or in INR with GST is 44,997. If you are joining as a group, 2 to 3 learners, 5% discount, 4 to 7 learners, 10% discounts, 8 to 15, 15% discounts, and 15 plus learners, you are going to get 20% discount. Right. So this is the pricing architecture. If you want to pay in lump sum in a one shot, so we can talk about some discounts as well that we can discuss offline. Right. So at this stage, that's all what I've got. We will open for questions. So if you want to know anything about me, you can reach out to me at this particular number, 9871014894. Feel free to reach me out for any questions, any comments or feedback related to the course or related to the session. Right. With this, let me look at the chat box, and there were a couple of chats, a couple of messages in the chat box. Let me have a look at it. So Vinod says one more question. If we are taking about Vinod, I'm not able to understand the question. What do you mean by taking about up on and for which user traffic is? Okay, I'm not very sure about the question. When AMA will provide slice as a, okay, no, that's okay. Talking about up on and for user plane. Okay, no, as of now we are not getting into the discussion as of now, right? So that's a detailed discussion, and there are 2 or 3 different use case scenario. Why do we use user plane on the info interface? When AMF provides slices, configured slice and registration except message, when AMF will provide slice as a configured slice. So when we talk about NSSCI values, there are different type of NSSCI values, and a collection of it is called as NSSCI. There are different type of information, configured slices, allowed slices, rejected slices, subscribed slices. There are a lot of different features. So I'm not sure what exactly is your question, Sabir. Let me look at any other questions. For SMS delivery, there are typically two procedures. One is via NAS, one is via VoIP, or I'll say IMS. Depends how we want to implement, right? So there are two different procedures about the SMS delivery. Any other questions? Okay, if no questions, that's okay. Let me share my details here. If you want to connect to me on LinkedIn, if you are not connected already and wish to connect to me on LinkedIn, you can hit me up on this particular URL. Second, if you want to look at the recording of this session, you can subscribe to our YouTube channel or search Telcolan on YouTube. I'm sharing the link of that. Right, and I've already shared my mobile number with you. If you want to connect to me, you can connect on this particular number. Thank you very much. I hope you enjoyed the session. Please keep in touch and let us discuss more. Thank you very much. Have a great day. Take care.